All right, so we're asked to find the total area of the regions between the curves y equals 6x squared minus 18x and y equals negative 6x from 1 to 3. And so that's one thing that I want us to keep in mind. This question says regions, not region. And why might that be important? Well, here's what might be happening. Let's say from 1 to 3, our first graph, I'll draw it in red, our first graph might look something like this. Right? And then our second graph, and I'll draw that in blue, might be something like this. Where you can see that for a portion of time, like from here to here, the red curve is above, and for a portion of time, and I'll do this one in green, the blue curve is above. And so we need to figure out, well, is this curve intersecting somewhere? What might be happening? What might cause there to be different regions? So in order to find intersection points of our curves, we have to set them equal to each other. So we want to see, when does 6x squared minus 18x equal negative 6x? I'm going to rearrange this by adding 6x to both sides. So I'm going to get 6x squared minus 12x equals 0. I'm going to factor out a 6x. And by the zero product property, I can find that here, x equals 0 or x equals 2 will be intersection points. So on our example here, we can look at this. There's 2. There's that intersection. We don't really care about x equals 0, and why not? Well, if we look at the top of the question again, we can remind ourselves that we're just looking from 1 to 3. So that means at 1, from 1 to 2, one of the functions is on top, and then from 2 to 3, another function is on top. But we don't know which one is which. So how do we figure that out? Well, we can test it. Where do we care about, 1 or 3? It doesn't matter, because at the other one, the other function will flip over. And so let's just test when x equals 1. What's going to happen for both functions? For the first one, y equals 6 times 1 squared minus 18 times 1. And then the other function is negative 6 times 1. So let's figure out which one will be on top. 1 cubed, or 1 squared is 1, 6 times 1 is 6, minus 18. This is going to give us negative 12. And this one will give us negative 6. Which one is more positive? Which one's going to be higher? I can see that that is this one right here. Let me highlight it in green. We can see that it's this one. It's the one that gave us our negative 6 value, which is y equals negative 6x. So that means we can say from 1 to 2, from x equals 1 to x equals 2, y equals negative 6x is on top. And then we can just assume that after that, it's going to alternate, right? And so after that, so from x equals 2 to x equals 3, the other function, y equals negative, or y equals 6x squared minus 18x is on top. What do we do with this information? Well, now we can make our integrals. I'll do this in black here on the side. The first integral is from 1 to 2. And we take our top function, whichever one is our higher value, so that's negative 6x. And then we subtract our other function, which in this case was 6x squared minus 18x with respect to dx. And then what do we have to do? We also have to add our other equation. So add the integral from 2 to 3, and now they switch spots. The function that used to be above is now below. And so we can write it as 6x squared minus 18x minus negative 6x with respect to x. Now, what do we have to do here? Well, we have to simplify so we can find the actual integral from 1 to 2. Negative 6x, that minus will distribute, and I'm going to move things around. So we're going to end up with negative 6x squared plus 12x with respect to x, plus the other one will be the integral from 2 to 3 of, here, that subtraction will distribute. 6x squared minus 18x plus 6x is going to leave us with 6x squared minus 12x with respect to x. All right, so now we have these two integrals, and what do? Well, we solve these. We use the power rule for integration. We're going to get negative 6x cubed over 3 plus 12x squared over 2 from 1 to 2, plus here 6x cubed over 3 minus 12x squared over 2 from 2 to 3. What do we do with this information? Well, we just solve it out, but I see I can simplify it a little further. Negative 6 divided by 3 is going to give us negative 2, so this will be negative 2x cubed plus 6x squared from 1 to 2. Plus, I'm going to put these in brackets so we know it's separate from everything else, plus 2x cubed minus 6x squared from 2 to 3. All right, now let's plug in our values so we can figure this out. I'm going to now use green so we can see that we're finding our final answer, these areas. I'm going to plug in my values. Actually, I'll do green for this first one. So equals negative 2 times 2 cubed plus 6 times 2 squared minus negative 2 times 1 cubed plus 6 times 1 squared. And then here we're going to subtract, or not subtract, add the other side, which I'll do in red. I'm going to zoom this out just a little bit so we can see all this work. 2 times 3 square cubed plus, or sorry, not plus, minus 6 times 3 squared minus, sorry about that, minus 2 times 2 cubed minus 6 times 2 squared. All right, so now we just math it out. 2 cubed is 8 times negative 2 is negative 16, so we get negative 16 plus 2 squared is 2 plus 24 minus negative 2 plus 6. All right, and then we add here. 3 cubed is 27 times 2 is 54 minus 3 squared is 9 times 6 54. Oh, that's kind of nice. Minus 2 cubed is 8 times 2 is 16 minus 2 squared is 4 times 6 is 24. All right, now we're just going to simplify. I'm going to do this final simplification in blue. Negative 16 plus 24 is 8 minus 4 plus 0 minus negative 8. This becomes 4 plus 8. And after all that, we find that the final area inside both of these is going to be 12. So our final answer is B. What are the steps that we took here? First, we found where are the intersection points for our integral, and then we also tried to figure out which function is going to be on top when. And once we discovered that, we were able to set up our integrals, and we solved this just like any other integration question. It might have seemed a little bit complicated or confusing at first, but once you know how to set up the problem, it works the same every time.